Okay, so today we will discuss all about the electron configuration. So this is part of the second quarter, module 1. What is electron configuration? Electron configuration is the arrangement of electrons in the orbitals of an atom. The electrons in an atom are arranged in shells that surround the nucleus. So we have here the first energy level or shell. The symbol is N. First energy level, second energy level, the third energy level, and the fourth shell or the fourth energy level. The farther the energy level from the nucleus of the atom, the higher the energy. So the highest energy here in our diagram is energy level 4 or the fourth energy level. You can see the arrangement of the electrons in each orbital. Electron shells consist of one or more subshells. We have different sublevels or subshells. The first one is the S sublevel. It means sharp. For the second sublevel, we have the P sublevel or principal, D diffuse, and F fundamental. For the first energy level, we have here S sublevel. For the second energy level, we have S and P sublevels. For the third energy level, S, P, and D sublevels. And the fourth energy level, we have S, P, D, and F sublevels. Now, we can compare the energy level or the sublevel in a building. So we can say that, let's say we have here the building. So the first floor of the building, this is the energy level. First floor is the energy level, and the sublevel is the room. So in our first floor, we have only one room, which is the S sublevel. Same in the second floor. So in the second floor, this is the second energy level. Okay, and the rooms, we have two rooms. We have the S sublevel and the P sublevel. And for the third floor of the building, this is the third energy level. And the rooms are S, we have P, and D sublevel. And the same with the fourth floor. This is our fourth energy level. And we have four rooms. The S, the P, D, and F. The sublevels or the subshells consist of atomic orbitals. So what are atomic orbitals? Atomic orbitals are the volume or the place where the electrons are most likely to be found. For the S sublevel, we have spherical shape. So this is the shape of the place where the electrons are most likely to be found. And for the P sublevel, we have peanut or dumbbell shape. And for the D sublevel, we have double peanut shape. And for the F sublevel, this is the flower shape. Here is the shape of the probable location of the electrons. If you can see here in our diagram, this is the S orbital. S orbital is spherical shape. The black dots are the probable locations of the electrons because we cannot determine the exact place of the electrons around the nucleus. Electron configuration describes where electrons are located around the nucleus of an atom. For example, we have lithium. The symbol is Li. The electron configuration of lithium is 1s2, 2s1. So, in the lithium atom, for the first energy level, we have 2 electrons. And for the second energy level, we have 1 electron. Another example, hydrogen. The electron configuration of hydrogen is 1s1. So, in the hydrogen atom, the first energy level has 1 electron. So this number indicates the energy level. And S indicates the type of sublevel or subshell. And the superscript indicates the number of electrons. So going back here in our example, in the lithium, we have here 1s2. So in the first energy level, the type of subshell or the type of sublevel is S. And the number of electrons in the energy level is 2. So we have 2. Okay. And next one is 2s1. So in the second energy level, the type of sublevel is S. And the number of electrons is 1. So we have here 1. The same here in the hydrogen. So we have here 1 energy level or the first energy level, the type of sublevel, which is S, and the number of electrons, which is 1. In writing the electron configuration, we have 3 rules. The first rule is the Aufbau principle. Second rule is the Pauli's exclusion principle. And the third rule is the Hans rule. In the Aufbau principle, it is also known as the building up principle. It states that electrons occupy orbitals in order of increasing energy. It follows the mnemonic device. Here is the mnemonic device. This will serve as our guide in writing the electron configuration. Here we will start in 1s, next 2s, the next is 2p and 3s. All you have to do is to follow the arrow. Okay? So after the 2s, we will start in 2p, then followed by 3s. Then after 3s, we will proceed to 3p. Okay? And 4s. So dito nalilito yung so dito talaga nalilito yung ibang bata na ang ginagawa nila, they go with the flow. So, 1, 2, 3, 4, 5. Doon nagkakamali. So, you have to look or follow the arrows. So, yung first arrow natin, so 1S muna. Then, next is 2S. After 2S, 2P na tayo. Okay? Then, 3S. Then, tatalon tayo sa 3P. Next is 4S. Okay? For example, lithium. The electron configuration of lithium is 1s2, 2s1. We will start in the 1s. The next 2s. If you can see, the above principle is the building up principle. It means that we will start in the lower or in the lowest energy, which is 1s. Okay. Notice that 1s is filled first before moving to 2s. It means that 1s has lower energy than 2s. Mag-i-start tayo sa pinakamababa hanggang sa mataas na energy level. In our mnemonic device, as we go down, the energy is increasing. Now, let us write the electron configuration of oxygen. So how to write the electron configuration? First step, you have to know the atomic number of the element. Using the periodic table, you have to look at the atomic number of oxygen. Second step, identify the maximum number of electrons in each sublevel. In S sublevel, it can hold up to 2 electrons. P sublevel can hold 6 electrons. D sublevel can hold 10 electrons. And the maximum number of electrons for F sublevel is 14. Third step, you have to use the mnemonic device of electron configuration as your guide. Okay, so let's do the steps. Let's write the electron configuration of oxygen. The symbol of oxygen is O. Now, the first step is to know the atomic number of the element. So we have to use the periodic table. Now, in the periodic table of elements, here is the oxygen. The atomic number is 8. Now, let's write the atomic number. The atomic number is equal to the number of electrons. Next step, we have to identify the maximum number of electrons in each sublevel. Again, the maximum number of electrons that the S sublevel can hold is 2 electrons. For the P sublevel, it can only hold up to 6 electrons. D sublevel, 10 electrons. And for the F sublevel, 14 electrons. For the third step, we have to use the mnemonic device. So, Here is the mnemonic device. Let's start with the low energy. We have here the 1s. So let's write 1s. The maximum number of electrons that the S sublevel can hold is 2. We have to reach 8 electrons. Okay, so let's write here 1s2. Next, 2s. So let's write 2s. Again, the S sublevel can hold up to 2 electrons. Next, after 2s, let's have the 2p. 2p. The P sublevel can hold 6 electrons, but we only need how many electrons? 4 electrons, because we already have total of 4 electrons here. 2, then 2. So 2 plus 2, we have 4. We do need 4 electrons. So let's write here 4 electrons. So total of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. That's the total number of electrons in the oxygen atom. Another example, let's have chlorine. First step, you have to identify the atomic number of the element, because the atomic number is equal to the number of electrons. So let's take a look at our periodic table. Chlorine, the atomic number of chlorine, 9. Okay? Let's write here 9. It does mean that chlorine has 9 electrons. Second step, we have to know the maximum number of electrons in each sublevel. So we have here the copy already. Make sure you will not exceed to the maximum number of electrons. In the third step, let's use our mnemonic device. Okay, so same process. Let's start with the low energy, which is the 1s. Let's write 1s. We have to reach 9 electrons. Okay. Again, the S sublevel can hold up to 2 electrons. Let's write 2. Okay. Next. The next energy level is 2s. Let's write 2s. Again, the S sublevel can hold up to 2 electrons. So let's write 2. So how many how many electrons do we have here in our electron configuration? We have a total of 4 electrons. We do need 5 more to reach 9 electrons. So let's proceed. Let's move to, after the 2s, we will have the 2p. Okay, 2p. Just follow the arrow. And the P sublevel can hold how many electrons? 6. Okay. We only need 5 electrons. So let's write here 5 electrons. Total of 9 electrons. So this is the electron configuration of fluorine. Lagi nyo tatandaan na hindi dapat kayo pwedeng sumobra doon sa maximum number of electrons. Okay? Ayan. Ang main goal natin is to reach the number of electrons of the atom. So, 9 ito. Okay? 9 yung atomic number ni fluorine. Therefore, we have 9 electrons. So, kailangan maka-reach tayo ng 9. So, mag-start tayo sa 1s. Let us follow this mnemonic device. Okay? Mag-start tayo sa 1s. So, lagay nyo dito yung 1s. And then, the s sublevel can hold up to 2 electrons. So, hindi tayo pwedeng magsulat ng 3. Kailangan 2 lang. Hanggang 2 lang yung maximum number of electrons niya. So, nalagay nyo dito ay 2. So, ilan pa natitira? 7. Kailangan pa natin ng 7 na electrons. So, mag-move pa kayo to another energy level. So, which is 2. After ng 1s, 2s. So, lagay nyo 2s. So, again, yung s sublevel, it can hold 2 electrons. So, nalagay nyo dyan 2. So, how many electrons are there? So, we have 4 na. Kailangan pa natin ng 5. So, hindi tayo titigil hanggang hindi tayo nakakarating ng 9 electrons. So, after ng 2s, pupunta tayo ng 2p. So, lalagay nyo dito 2p. Okay? Yung p sublevel, it can hold 6 electrons. Pero, ang kailangan natin ay 5 na lang. Okay? Kasi 9 lang naman ang kailangan natin dito sa fluorine. Huwag kayong maglalagay ng 6. It depends on the number of electrons. Napapansin ko kasi sa iba, di porket na 6 yung maximum niya, lalagay nyo rin 6. No. Magdedepende tayo sa number of electrons ng atom. So, ang natitira na lang ay 5. 5 na lang ang kailangan natin para reach tayo ng 9 electrons. So, 5 ang lalagay nyo dito, or 5. Okay? Hindi lang kayo pwedeng sumobra ng 6. Second rule, we have the Pauli exclusion principle. In the Pauli exclusion principle, only 2 electrons may occupy an orbital, and they must have different spins. We have here the table. In s sublevel, we have 1 orbital. In the p sublevel, we have 3 orbitals. In the d sublevel has 5 orbitals. And the f sublevel has 7 orbitals. Take note that in each orbital, it can only fit 2 electrons. So, there will be 2 electrons in 1 orbital. When 2 arrows occupy the same box, they should face in opposite directions. So, the arrows or half arrows are used to represent the electrons occupying the orbitals. Arrows or half arrows can point up or down. So, example, lithium. The electron configuration of lithium is 1s2, 2s1. Again, the orbitals are represented by box. Okay, box. So, for s sublevel, how many orbitals are there? We only have 1. Okay, so let's draw a box here for the 1s2. So this is for the 1s2. Okay. Now, in each orbital, we have 2 electrons. Okay. And the electrons are represented by arrows or half arrows. So, how many electrons do we have here in the s sublevel? We have 2. Very good. So, how many arrows do we need to draw? 2 as well. So, let's have here 1 arrow. Okay, it is represented by arrow or half arrow. Okay. Again, in the Pauli exclusion principle, the arrows should face in opposite direction. So, 1 arrow point up and another arrow point down. Okay. And next one, for the second energy level, the S sub level again. The S sub level, how many orbitals? We have 1. So let's draw a box. 1 box for the second energy level, and the sub level is S. How many electrons? 1. So how many arrows do we need to draw? 1 as well, and it is pointing up. Okay, so remember that the arrows should face in opposite directions. If you draw like this, okay, this is wrong. The arrows should face in opposite direction. Okay. Third rule, Hans rule. In filling up a set of orbitals, the orbitals are occupied by 1 electron at a time, with the electrons having the same spin. Again, let's have the table for the number of orbitals. Let's have the nitrogen. The electron configuration of nitrogen is 1s2, 2s2, and 2p3. Now, let's draw the orbitals. For the first energy level, the sub-level is S, and the number of electrons is 2. Now, in the S sub-level, how many orbitals are there? We have 1. Okay, very good. So, let's draw a 1 box. Next one is 2s2. So we have S sub-level, another box, and next is 2p3. In the P sub-level, we have 3 orbitals. So let's draw 3 boxes. Okay, now let's draw the arrows. Remember the second rule or the Pauli exclusion principle, the 2 arrows occupy the same box. They have or they should face in opposite direction. So let's draw the electrons or the arrows in the first energy level. So we have 2 here. So we will draw 2 arrows in opposite direction. Spin up, spin down. Same here in the 2s2 for the second energy level. We have 2 electrons, 2 arrows. Spin up and spin down. And for the 2p3, we have here 3 electrons. So we will draw 3 arrows. But in the Hans rule, remember that the orbitals are occupied by 1 electron at a time, with the electrons having the same spin. So we will spread out the electrons or the arrows first. Example, 1, 2, and 3. Okay, it is like riding a bus. let's have here a bus. Okay, here are the chairs, and in the bus on the left side we have 2 chairs. Okay, and each chair has a passenger. Let's say there is a passenger here. Now when you ride on the bus, you will go to the empty chair. Okay, you will go to the empty chair. So ibig sabihin, pag sasakay kayo ng bus, di ba, pag may mga nakaupo na dyan, hindi mo naman makakilala yan, ang common na ginagawa natin is umupo tayo dun sa walang tao. So ganun din dun sa hands rule. You have to spread out the arrows first. So spread out nyo muna with the same spin. So up, up, up. Okay. Huwag kayo agad magda-down. So kailangan nyo munang punuin yung boxes dun sa P sub-level natin bago kayo mag-down. However, hindi na tayo magda-down kasi 3 arrows lang naman ang kailangan natin dito. Okay. Another example. For the oxygen, the electron configuration is 1s2, 2s2, 2p4. So the same lang din dito, no? So ito yung sa 1s2, spin up, then spin down. For the 2s2, spin up, then spin down. Now dun sa p sub level, yung p sub level natin again, it has 3 orbitals, diba? So yan, may 3 orbitals yan. Sulat ko na dito yung electron configuration. So 1s2, 2s2, then 2p4. So kailangan meron tayong 4 arrows dito sa box o dito sa orbital. Okay. Now, in the hands rule, 1 electron at a time muna tayo. 1 electron at a time with the same spin. So, spin up. Huwag muna kayo mag-spin down. Okay, that's wrong. Punuin nyo muna yung box. Okay. Spread out the arrows. So, another arrow. Same direction. Then same direction. Okay. Bago kayo mag-spin down. Kasi kulang pa tayo. Ilan ang kailangan natin? 4. Okay, 3 arrows pa lang yan. So, kailangan makita natin 4 na arrows kasi 4 yung electrons natin. So, 3 lang yung orbitals ng P. Yung pang isang electron, pumunta ulit tayo dun sa first orbital with different direction na. Lalagyan natin yung spin down. Okay? Okay, let's try to check your understanding. Write the electron configuration of the element and show the orbital diagram. Let's have carbon. Remember, the first step is to know the atomic number of the element. Second step, identify the maximum number of electrons in each sublevel. And the third step is to use the Mnemonic Device of electron configuration as your guide. You may pause this video for a while and try to write the electron configuration in your paper. Then if you're done, just play this video again. Okay, let's check your work. The electron configuration of carbon is 1s2, 2s2, 2p2. I hope you got the correct answer. Now, let's draw the orbital diagram. Now remember that in each sublevel, there is a specific number of orbitals. Remember the rules. The Pauli exclusion principle, there should be 2 electrons that occupy an orbital, and they must have different spins. And the next rule is the Hans rule. In filling up a set of orbitals, the orbitals are occupied by 1 electron at a time with the same spin. Now, try to pause this video again and try to draw the orbital diagram in your paper. Now, let's check your work. Okay, we're done with the lesson 2. If you have questions, don't hesitate to type your questions in the comment section below.